Welcome to Train Signal. You're watching a video about planning for high availability. In this video, we're going to start off by defining exactly what high availability means. Then we'll take a look at some of the solutions involved, including DNS round robin, network load balancing, and failover clustering. Then we'll look at some of the storage solutions which are used with failover clustering, including RAID and SANs, or storage area networks. And then we'll also look at the quorum models that are used by failover clustering. So, what exactly does high availability mean? I mean, that's a term we hear all over the place. Well, high availability uses a combination of redundancy and fault tolerance in order to provide a level of operational continuity. Now, to overly simplify this, it means keeping things available, keeping things up and running at all times. Now, when we talk about redundancy means that there is more than one instance of a resource available. And then fault tolerance means that the resources will remain available even in the event of a failure. I used to give a definition when people would ask me, they'd say, what does fault tolerance mean? I used to say that we'll be tolerant of a fault because really that's what it means. It means if there's a fault or a failure that we'll be tolerant of it and things will remain available. And that is the idea behind high availability. Now let's take a look at some of the ways that we provide this high availability. And the first one I have listed here is something called DNS round robin. Now, DNS round robin is used to provide more than one IP address to a single host name. Now, each one of those IP address represents a different physical host or a different physical computer, or we could say physical server. And then the requests from the clients will be sent to each of those hosts or servers in a rotation type order. So what that basically means is that a request that comes in, matter of fact, I'll tell you what, let me show you a drawing of this. Here we have 3 servers, and as you can see here, they all have the host name of server 1. But they have 3 different IP addresses, right? Because each one has its own unique IP address out on the network. Well, what it means is when a request comes in, that first request may be sent to this guy right here, and then the second request that comes in would be sent to this guy right here, and then the third request that comes in would be sent to this guy right here, and then the fourth request, well, that's going to go back to this guy right here. Okay, and that's what we mean by round robin. Each server will take its turn serving the client's needs. Now, we can take DNS round robin to an extra level by enabling something called net mask ordering. When you enable a net mask ordering, this can be used to help send requests from clients to the host, or again, think of that host as server, to the server that is closest to them. Okay, so in the example that we had here, all 3 servers were on the same subnet, but if, as a for instance, if maybe this one up here was to be on the 192.168.10 network, and then maybe this one we could say is on the 192.168.11 network, and we'll take this one and make it on the 192.168.12 network. When a client makes a request, a client coming in from the 10 network, well, then that client's going to go ahead and be sent to the server that's also on the 10 network. And so that way, it's not necessarily a full-blown round robin, but rather you get some assistance with clients being sent to the server that's closest to them. Now, let me see if I can show you this in Windows Server 2008. To illustrate DNS round robin, we need to go ahead and connect with one of our DNS servers. So I'm going to go ahead and connect with New York DC1 because that is one of the DNS servers in the Global Mantics network. So what I'm going to do is go ahead and click on Start, Administrative Tools, DNS. Okay, this will take us into the DNS administration utility. And in the DNS manager here, what I want to show you is if I expand forward lookup zones and just click here, we have globalmantics.com. Here I want to show you, and this was from a previous video, we have New York member 1 listed as 192.168.10.1, and it's also listed as 192.168.11.1. By creating multiple A records, see right here it shows an A record or a host record. By creating these multiple A records with the same name pointing to multiple IP addresses, believe it or not, we're done. We've enabled DNS round robin, and we've even enabled net mask ordering. Now, to prove this, I'm going to show you exactly where those settings are set. So that way you'll know how to turn off round robin and or net mask ordering if you want to. But by default in Windows Server 2008, they are enabled. What you need to do is right click on the server itself and go to Properties. In the Property sheet, you want to go to the Advanced tab. And then right here, you'll notice that there's a box that's already been checked for enabling round robin and a box that's been checked for enabling net mask ordering. So because these are such common settings that you would most likely want to use. I mean, if I cancel out of here, if we go back here and look, if I've taken the time to set up 2 A records for the same host name pointing to multiple IP addresses, odds are I want to have some kind of rotation to it. I don't want everything just going to the same host all the time. I want to go ahead and rotate between them. And then, of course, net mask ordering helps because then it sends clients to the host or server that's closest to them. So for that reason, Microsoft has made it that both of those features are enabled by default in Windows Server 2008. Now, the next feature I'd like to talk to you about when it comes to high availability is something called network load balancing, or what's commonly referred to as just simply NLB. Now, network load balancing uses a more sophisticated form of distribution than DNS round robin. I mean, remember, by default, DNS round robin is going to either A, just rotate from server to server, or B, send a client to the server in the round robin group that is closest to it based upon its subnet. With an NLB cluster, all of the servers that participate communicate with each other using something called a heartbeat and convergence. And the convergence is going to be based upon either the addition or the removal of an additional server, or when one of the servers misses a heartbeat. Now, the heartbeat is pretty much just a way of all the servers continually letting each other know, hey, I'm still here, hey, I'm still here, hey, I'm still here, hey, I'm still here. But if a heartbeat is missed, now it's as though a server is not there, and when that happens, all the other servers will know about it. Now, using NLB, a client that makes a request will be directed to the server which is most readily available to serve that client. So all the servers in a network load balancing cluster are going to know about all the other servers. They're going to know the status of the other servers, and therefore they will be able to communicate with each other and decide who is the most available server to provide the resources necessary to that client. Now, Windows Server 2008 includes a utility called the Network Load Balancing Manager, which allows you to easily manage your network load balancing clusters. So let me show you exactly how we would get to the Network Load Balancing Manager in Windows Server 2008. All right, so back here on New York DC1, if I want to access the Network Load Balancing Manager, I have to first install the feature. So I'm going to click on Start and take us to Server Manager, because that's where we add our features. I want to put a quick emphasis in the fact that it is a feature and not a role. Sometimes it's hard to keep straight what's a role and what's a feature. But if I click on Features and then click on Add Features, you will see here that there is network load balancing. If I check that box, then I will have network load balancing available on this server and then have access to the management utility. Now, before we leave this screen, I want to also point out to you that there's another feature right here called failover clustering. And that's the next thing that we're going to talk about. And I just wanted to point out to you that both of these are considered to be features on a Windows Server 2008 computer. Now, I'm not going to worry about actually adding these features right now because we're not going to get into the actual screens right now. Let's go back. Let me cancel out of here. Yes, I want to cancel. Let's go back and let's talk about failover clustering. So when it comes to failover clustering, we're kind of looking at a slightly different animal than what we were looking at with DNS round robin and with network load balancing. See, DNS round robin and network load balancing are used to provide high availability for services and applications which maintain an internal data store. Okay, so an example of where you might use network load balancing would be with different networking services. Matter of fact, DNS is one of them. I mean, I know DNS round robin obviously makes you think, oh, DNS, but network load balancing can also be used with DNS services. Another good example might be like web servers. Network load balancing is great if you want to have a farm of web servers. It will take a client to the most available web server. Failover clustering, however, is used for applications which use an external or shared data store. And a typical example of that might be something like SQL Server or Exchange Server, something which has a very defined database which is shared and is typically needed to be kept in a central location. So servers in a failover cluster, again, use shared data where servers using NLB each maintain a copy of the data themselves. Okay, so that's one thing to keep in mind. Now, failover clusters also will typically use some form of shared disk technology such as RAID or SAN or Storage Area Network, which we'll talk about those in just a moment. But just to kind of illustrate, here we have a network load balance cluster. And you'll notice that on each of these three servers, they have their own copy of the data maintained on the individual server. Now, this is something to really keep right on the front of your mind when deciding whether to use NLB or a failover cluster. And the reason why is because you can really get into trouble if there is an external database in which you're using an NLB cluster, and then maybe each of these three servers, although the clients are going to go ahead and be directed to whichever server is most readily available with the services, well, they might have a slightly different copy of the database if that's all you're using is NLB. Because one client might come to one server and make some changes to the database, and another client, well, they get sent to a different server, and then they won't see those changes, and maybe they make changes of their own. So that's something to definitely be cautious about when it comes to NLB. If you do have that external or shared data, well, then you want to use the failover cluster where each of the servers are providing the services that the client needs, but they all are accessing this same shared database. Okay, the data is all centrally located and then distributed from that central location to each of the machines every time it's accessed. Okay, so that's something to definitely keep in mind. And along those same lines, I'll tell you what, it's not uncommon at all to have both NLB and failover clusters working together. It's not uncommon at all to have, let me give you, for instance, if we could be talking about web servers or possibly SharePoint servers, both of which are services which can be network load balanced, but then also have a database of information that needs to be accessed as part of those services, which would then be maintained in the form of a failover cluster. Now, speaking of storage solutions necessary for failover clusters, The first thing I want to make sure that you are familiar with is something called RAID. Now, RAID actually stands for redundant array of, now it's interesting, the I can be for two different words. It could be redundant array of independent disks, or sometimes it's referred to as redundant array of inexpensive disks. Technically, I believe it's supposed to be independent disks, but it is very often referred to as inexpensive disks because the idea is you get an entire array of smaller disks, and therefore, because they're smaller, they're going to be inexpensive. But anyway, what is RAID? Well, it's an array of disks which all work together. So here I have an example of what could be considered a RAID box. It's a computer that has a bunch of hard drives in it. And those hard drives all work together in the form of an array. Now, there is both hardware RAID and software RAID. Most people will tell you that hardware RAID is preferred. Microsoft does include software RAID in all of their server operating systems. So within the operating system itself, it can manage access to this array of hard drives, but then you're relying on the software itself or the operating system itself to be functional. Whereas with hardware RAID, there is a separate controller which is controlling access to the individual hard drives without any reliability on the operating system. Anyway, the other thing I need you to know is I need you to be familiar with the different types of RAID. Now, there are many more than the 4 that I have listed here, but these 4 are the primary ones. Well, really, these top 3 are the primary ones that I want you to be familiar with. And as a matter of fact, these are the same 3 that are available in Microsoft's software version of RAID. Now, the first one, RAID 0, it's called striping. And what this means is that the data is striped through the array of hard drives. So what it basically means is, like down here I have the 4 hard drives. It means that as I save data, I'm going to save a 64 kilobyte chunk of data to this top drive, and then I will move down and save the next 64 kilobyte chunk to this drive, and then this drive, and then this drive, and then I'm going to actually rotate back up and save it back up here, and then here, and then here, and then here, etc., etc. I think you get where I'm heading with that. We are striping the data amongst all the drives. Now, I will tell you that this is not fault tolerant. So, in other words, if we were to lose one of the drives, that's it. We're toast. The data is gone because essentially 1/4 of the data, and not even like a chunk 1/4, but every 4th block is gone. So why would we use RAID 0? Well, we might use RAID 0 for performance reasons, not for fault tolerance reasons. When you are accessing the data off of this striped array, if you have bus mastering hard drives, meaning each drive works independently and doesn't have to wait for the other, well, what we can do is we can essentially be reading from all 4 of these drives at the same time. Therefore, we can read the data, well, a theoretical 4 times as fast as we could if it was on a single drive. But I'll tell you what, in this video, we're talking about high availability. So really what we need to talk about is the fault-tolerant versions of RAID. Now, with RAID 1, which is called mirroring, you would use exactly 2 hard drives. So let's just kind of pretend like these 2 don't exist. All we have is 2 hard drives. And with RAID 1, it works just how it sounds. I mean, if we're going to describe mirroring, well, what do you think of? Well, everything that gets written to one drive, an exact duplicate mirrored image is put on the other drive. Now, this is fault tolerant. And what I mean by that is if we were to now lose one of the drives, that's okay, because an exact duplicate copy of the data is on the other drive and could still be accessed. Now, the downside to using mirroring may seem fairly obvious, and that is that you only get 50% disk space utilization. And what I mean by that is if I buy two 500 gig hard drives, well, I've purchased a terabyte of storage, right? I've purchased 1,000 megabytes of storage, but I can only save 500 gigabytes worth of data because everything that I put on one, I must also put a copy on the other in order to have this fault tolerance. So that's the one negative to using mirroring. Now, the next form of RAID I want to discuss is something called RAID 5, and this is known as striping with parity. So what we're going to do is we're going to go ahead and stripe the data in the 64K blocks just like we did in RAID 0. Right? We go ahead and write the data on one drive, then the next drive, and the next drive, and we just keep striping it. But there is one significant difference, and that is that on each pass through, instead of writing just data, one of the drives, we will go ahead and write a parity block instead of data. Okay, so the check marks that I'm circling would represent the drive that we're storing the parity block on instead of data itself. And in this instance, what happens is if we were to lose a drive, and so here we'll say we just lost all this data right here, what we can do is go down to the parity blocks and restore the missing data. Now, once we have lost that one drive, I will tell you that we're no longer fault tolerant. Okay, RAID 5 only allows you to lose one disk out of the array. But once that disk is lost, the parity block replaces the missing data. And then you're just essentially reverting back to RAID 0 at that point until you are able to replace that disk and get your RAID 5 parity blocks restored. Now, one of the advantages, or really a couple of advantages to RAID 5, is that unlike mirroring, where we only get 50% disk space utilization, when it comes to RAID 5, well, we get better disk space utilization, but it's not a set amount. In this example, where there's 4 drives, I would get 75% disk space utilization. And the reason why is because 3 of the 4 drives are going to have data, and only 1 is reserved for parity. Okay, so you get 3/4. If I were to have an array of 10 disks, well, then I would have 90% utilization because 9 of the disks will have data and only 1 will have parity. The other advantage is that we get the read acceleration that we get with striping. When we go to read the data off these drives, again, we're reading off multiple drives simultaneously, and so we can read faster than we could off a single drive. The downside to using disk striping with parity is that the write time, write with a WR, WR write, like we're writing something. When we're writing the data, it takes longer because as we write the data, we have to calculate the parity. So that is pretty much the 3 forms of RAID that you need to be familiar with and that are included with Microsoft's operating systems. Now, one little side note before we go any further is that if you need to have fault tolerance, only RAID 1 can be used with the operating system volume. Okay, so essentially your C drive, or the one that contains your operating system, if you're going to use software RAID, you can only use RAID 1, whereas RAID 5 can then be used for the data itself. And this is not uncommon. If you're going to use software RAID, it's not uncommon at all to go ahead and have a couple of drives set up for RAID 1 with mirroring, and then another set of however many drives for the data with RAID 5. Now you'll see there's one more form of RAID that I have on the screen here, and that is RAID 10, or what's really more appropriately called RAID 10. Sometimes it's even referred to as, it's written as 1+0. The thing to keep in mind is there is a difference between RAID 1+0 versus RAID 0+1. Okay, there is actually a difference. And that's why, by the way, it's not really supposed to be called RAID 10, is because obviously RAID 0+1 couldn't just be called RAID 1, or heck, that would just be mirroring. Now, what RAID 10 or RAID 1+0 is is referred to as striped mirrors or a stripe of mirrors. Basically, all you're doing is you're taking RAID 1 and RAID 0 technology and putting it together. RAID 1 plus 0, or RAID 10, or RAID 10, or however you want to call it, refers to a bunch of mirrors that are striped. I know this can get a little bit confusing, but basically RAID 10 would be where we have, let's say, 6 hard drives, and the way they would be configured is in 3 mirrors. And then those 3 mirrors will then be striped. Versus if we were to say RAID 0 plus 1, what you're going to have is you're going to have a mirrored stripe where you could have those same 6 drives, but what's going to happen is you're going to have 3 drives set up as a stripe, another 3 drives set up as a mirror of that stripe. Anyway, if you're kind of confused about the difference between RAID 10 versus RAID 01, don't really worry about it other than keeping in mind that it's a combination of 1 and 0. That's kind of the bottom line. And along those same lines, I will tell you that there are also versions of RAID out there which are called 15 and 51 and things like that, which are, again, just a combination of RAID 1 and RAID 5. Now, when it comes to working with SANs, or storage area networks, basically what it comes down to is a bunch of scary acronyms. And really, that's what it is. Anytime anybody starts to learn anything about a SAN, they instantly become intimidated with all these different acronyms. And there's just no way of getting around it. But let me see if I can go ahead and explain what some of these acronyms are. First one we have here is something called a logical unit number, or a LUN, or I suppose some people might call it a LUN. I always refer to it as a LUN. A LUN is a number assigned to a logical unit, and really I should say a logical unit of storage. Now this logical unit of storage can be a single disk, or it might be an array of disks, right? It might be one of these RAID arrays. Okay, but basically a LUN is nothing more than a number within our storage area network that represents an area of storage. Now, the next one we have here is the Virtual Disk Service, or VDS, which is an API. I'm explaining one acronym with another one. An API is an application programming interface, which allows for a standard set of Windows tools to be used for complete storage management, even in the event that you have a mixed storage environment. Basically, this virtual disk service is something that you can go ahead and implement with each of your different forms of storage so that you can use one disk management utility basically to go through and manage all these different units of storage. Because otherwise, we would have to go to a different management utility for each different type of storage unit. So again, just to simplify it, a VDS, Virtual Disk Service, allows for an administrator to use standard Windows tools regardless of the form of storage that they're using. Now, Multiple Path Input-Output, or MPIO, is a feature which allows a server to use multiple data paths to access a storage device. So really what this is a form of high availability between a server and storage. Because a storage area network, the data itself is going to be stored outside of the physical server. You can have multiple servers all trying to access this one centralized area of storage. Well, as a specific server is trying to access that storage, well, that line of communication could go down. But with multipath input-output, now we have high availability, redundancy, fault tolerance built into even that connectivity. Now, iSCSI, matter of fact, I'm going to take this a step further, and I'm just going to flat out say, look, there's one very, very distinct difference between using iSCSI versus fiber channel connectivity to a SAN. And that is, to keep this really, really, really simple, is that you use iSCSI when you are going to work within your own existing Ethernet network. Okay, if you don't want to have to go out there and implement a whole new line of connectivity, iSCSI is a protocol which will utilize the traditional networking technologies. It will utilize the existing Ethernet network, versus Fiber Channel provides a direct, secure connection to the data store. And this will typically be separated from your existing Ethernet network. So if you have an environment where maybe you have to have a separate, secure form of communication for this data, maybe you have highly sensitive data, well, then you're going to go ahead and set up a fiber channel network, a fiber optic based network. And this network will be maintained separately from your existing Ethernet network. Now, the last thing that I want to go over with you in this video are the quorum models which are used by failover clusters. Now, before I go over each of the individual models, let me first explain what a quorum is. Well, a quorum is basically used to maintain knowledge about the failover cluster and what it can tolerate. Okay, so there are different types of quorum models based upon the different types of failover clusters that you might create. And again, the quorum is what's going to maintain the integrity of the failover cluster. Now, the first one we have here is something called node majority. Node majority is typically used when there is an odd number of cluster nodes. Or instead of saying cluster nodes, we could say servers, or servers participating in the cluster. When you have an odd number, you can use what's called node majority. And if you look at the words node majority, well, it means exactly that. It means that this particular failover cluster will remain available as long as more than half, or the majority, of nodes are available. So if we had 7 servers or 7 nodes participating in this failover cluster, and we set up node majority, then as long as 4 of those servers were still up and running, the cluster would still be available. Now, the second type we have here is something called node and disk majority. Now, this will be typically used when there's an even number of cluster nodes. So here we could say maybe we have, well, let's say we have 4 nodes on this particular cluster. And with node and disk majority, the cluster itself will remain available as long as half the nodes are available. So as long as 2 of the 4 servers are still available. And then also something called the witness disk is available. Now, the witness disk keeps a copy of this quorum configuration data, and although one server manages the quorum resource data, all the servers have a copy of this configuration information. So as long as the witness disk and at least half of the nodes are still available, then the cluster will still be available when you use node and disk majority. Now, the third one here is called node and file share majority, and I'll tell you what, this is essentially the exact same thing as node and disk majority, except for that there's a witness share instead of a witness disk. Okay, so basically the quorum will be stored on a network share rather than on a specific disk. Okay, so that's really the only difference. But otherwise, it works the same as far as having an even number of nodes, and as long as half of those nodes are available, we're good to go. The last quorum model listed here is something called no majority disk only. And this should only be used in test environments. This is not something that you would want to use in production, and the reason why is because the disk that contains the quorum information is a single point of failure. So in other words, there is no fault tolerance when it comes to the actual quorum configuration information. This is something that you would use just to maybe test a certain environment without having to worry about setting up a sophisticated quorum. Okay? So again, just to kind of review this, node majority is when you have an odd number node and disk majority, and node and file share majority is when you have an even number and then also a witness disk or a witness share. And no majority is when you are in a test environment. All right, well, that pretty much wraps things up for this video. And at this point, you should know how to describe what high availability is and know when to implement DNS round robin versus network load balancing versus failover clustering. And I will tell you, by the way, that when I say DNS round robin versus NLB versus failover clustering, that makes it sound like you would only implement one or the other. But the reality is it's an and or. There are many situations where DNS round robin, network load balancing, and failover clustering are all put in place to provide true high availability. You should also know how to describe the different types of RAID and the different components of a storage area network.